Quiet, please. In exactly 15 seconds, we'll be on the air. Rubinoff and his violin. This is Hugh Conrad suggesting that for complete... Rubinoff and the orchestra carry on with the overture. As a solo selection, Rubinoff draws the bow across his Stradivarius to play Green Eyes in his own inimitable style. We present Rubinoff and his violin.
And so, we're on the air. Let's see how the broadcast gets from the studio to your home. Of course, you don't hear the real sounds over your home radio. What you hear is a translation of the sounds. Sound travels in waves. The picture of a sound wave, if we could see it, would look very much like this. These sound waves, made by the musical instruments, travel in all directions at once. Some of them are hitting that microphone and being picked up by it. The microphone is simply an electrical ear, the ear of the broadcast listeners. It picks up sound waves and converts them into electrical current. The operation of the microphone is very similar to the telephone in your home. Any sound, such as music or a voice, pushes this metal ribbon back and forth, causing a corresponding back and forth movement in an electrical current. When I say 1, the ribbon moves back and forth. Watch again. 1. This action of the ribbon sends an electrical current along the wire that leads from the microphone. If I say 1, 2, 3, 4, the ribbon dances back and forth a lot of times and sends a lot of different currents down the wire. All the electrical currents from all the microphones are controlled and sent out to the transmitting stations. These currents form what we call the audio wave. a wave you can hear. The audio wave still looks like this after it has been changed into electrical current. We want to make this wave stronger, so we amplify it here in the studio control room and again in the master control room. Each time we amplify it, the wave looks a little bigger, like this. Now this wave must travel over wires to the transmitting station hundreds and sometimes thousands of miles from the studio.
Rubinoff and the orchestra now offer for your entertainment a rhythmic arrangement of Spring, Beautiful Spring.
The audio wave coming over wires from the studio is amplified again immediately after it reaches the transmitter. But the trouble with this wave is that it can't carry itself anywhere. So we have to produce another wave that will travel long distances and carry the audio wave with it. The audio wave looks like small water waves. It will only go a short distance, getting weaker and weaker, and finally dying out. In water, little waves can travel a long way if they hitch a ride on a larger wave. So for radio, we make a larger, more powerful wave to carry the little waves. This carrier wave is made by what we call the oscillator. The oscillator acts like an electric pump, producing smooth and steady power that looks like this. When the wave made by the orchestra goes into the transmitter, it is put together with the carrier wave by a process called modulation. The modulator controls the flow of the carrier wave and impresses on this flow the music of the orchestra so that the combination looks like this. The carrier wave supplies the power, and the wave made in the microphone writes its signature on it. The result is the radio wave. Now comes the job of making this radio wave strong enough so that it will get to your radio. In order that you may hear it, we have to amplify the current in these big tubes gradually through several stages. In the first stage, the wave looks a little bigger. Then it gets still bigger, more powerful, and finally, it thunders out of the power strong enough to carry it over a wide radius. This radio wave is then sent to the antenna from which it is released. It leaves the antenna as vibrations and travels in all directions with the speed of light. The wave spreads out for hundreds of miles, and finally, your own aerial picks up a small amount of the original vibrations. Radio waves from many programs are being picked up by your radio all the time. You can select any one you wish by merely tuning in your set to receive the same number of vibrations as a particular station is broadcasting. The radio wave is picked up by the aerial on your car and is carried into the radio set. This wave is still a combination of sound and carrier waves, and your radio set must separate them. This is done in a little device called the detector tube. You've seen one in your own radio. This detector cuts off the bottom part of the wave so that if we follow the top line of what's left, we have an audio current wave exactly like the one we made in the studio. Then the other tubes amplify this current, and as it reaches your loudspeaker, it moves the diaphragm back and forth and is translated into a very good likeness of the sounds you would hear in the studio. Listen.
You are invited to listen to this program at this same time next week, when we will again present Rubinoff and his violin.